Hi everyone. Today I'm going to start programming this beautiful drone that looks like a standard FPV drone. In reality, it was based on FPV drone. It has a flight controller from Matek, Matek H743 Slim version 3, I believe in this case. It has a standard analog video transmitter from GPRC. It has motors from T-Motor. It has Express LRS receiver for radio. And the only difference compared to standard FPV drones, it has a companion computer. It has a companion computer that allows us to run our own software here and communicate with the flight controller and implement fully autonomous missions. Moreover, since we have companion computer here, we have ability to connect to the companion computer, still have 3D printing artifacts. So we can connect digital camera to our companion computer in order to have video in much better quality rather than getting videos from another camera, for example. And after that, we can pre-process this video, implement our algorithms, and send video to the flight controller using our output that we have on Raspberry Pi Compute Module 4. That is our companion computer here for today. And digital camera, in this case, it's Raspberry Pi camera version 3 that produce good enough resolution compared to PAL or NTSC that usually are getting from our cameras. So our goal is to implement some methods that helps us to have some autonomous capabilities for this FPV drone and ability to manage it manually if needed, obviously. But the problem that we need not just a companion computer that is Compute Module 4 in our case, and going to run Linux, we need something called the flight controller. We need ability to communicate, establish communication between our companion computer and between our flight controller. And for this, we need to use some specific software for flight controllers. By default, Matek has Betafly, but Betafly is not the best option when we are talking about autonomous, when we are talking about communication and integration with companion computer. Better systems that have these abilities are Ardupilot and PX4. They are very similar. Ardupilot is an older system, but Ardupilot supports many different flight controllers, including flight controller from Matek. So Matek H743 officially supported by Ardupilot, or Ardupilot officially supported by Matek. In any way, there are many other microcontrollers, one from SpeedyB, even based on F4 microcontroller, some microcontrollers from Mamba, Diaton, and others. If you look at PX4, you will be able to see that not too many microcontrollers are supported, and all supported hardware are much more expensive, and even not possible to accommodate some software, some hardware inside this small 10-inch FPV drone. So that's why we decided to go ahead with Ardupilot. In case of Ardupilot and PX4, Ardupilot has a little bit different license. Both packages are open source, but Ardupilot has GPL 3, I believe, and it requires publish everything, all your modifications that you made into Ardupilot source code to open source as well. But we are not going to do anything like this. We are going to use Ardupilot as is, and all our software should be implemented on the companion computer. In PX4, you can modify PX4 source code for your drones, and you don't have requirements, if I remember correctly, publish everything into open source. So you can probably attach your own sensors and implement your own algorithms directly into PX4. But now let's start with Ardupilot, and our primary goal for today, do initial setup of Ardupilot for this microcontroller, having in mind that it has Betafly on the board, and we would like to set up initial parameters and make sure that our drone can potentially fly, probably not in the best way. We are not going to go deep in pit tuning, but PID tuning, but we should be able to at least launch our drone, and after that we can potentially create another video where we will describe how to tune this drone. So let's start. And first thing that we need to do, we need to connect this drone to the computer. But since we are going to modify firmware, we need to move this drone into DFU mode. There is a button on Matek. Where is my USB-C cable? I have to push this button and hold it, and after that connect my Matek to the computer. Done. And now it's connected to the computer in DFU mode. So I can start flashing it. In order to flash the drone, we are going to use STM32 Cube Programmer. Yes, you need to install this tool. Potentially, you can use Betafly or iNav if you have it installed in order to flash Ardupilot firmware as well. You just don't need to pick board name and Betafly version, but just download all needed firmware from a local computer. But I found that it's not always a working solution. So I prefer to use STM32 Cube Programmer, and obviously we need to download firmware. How to find firmware? Let's probably start from the beginning. If you go into Ardupilot website, you should be able to see downloads menu item here. And there is a submenu called firmware. I just click firmware. You can see that firmware are available for many different kinds of devices. In our case, we are going to have quadcopter for motors, and we have to pick stable and pick our board from the list. You can see too many different boards, and in our case, it's Matek H743. You can see two firmwares here. One is a standard one, another one with bidirectional D-shot support. Since we are using, in my case, AC-based AM32 that supports bidirectional D-shot as well, and my controller supports bidirectional D-shot, I'm going to pick the second one. So all what we need to do, just download hex file from here, Ardocopter with BL hex, and that's all. Once you have it on the local disk, you can open STM32 Programmer, and since we just connected down into DFU mode to computer, obviously we need to make sure that you installed all needed drivers. If you have problem with drivers, I still would recommend to have Betafly configurator. In case of Betafly configurator, there is a really great instruction about how to fix a problem if you have on your own computer, even if you believe that you installed the drivers. You can just go into instruction on Betaflight website, and you can see that they provide like all needed links how to install CLAP drivers that bridge UART. In case if there is any problem, there are some recommendations about what to do. For example, on this computer, I did not have any problems. I just installed drivers as this, and it worked very well. But if you have a problem, there is a recommendation to use the dig tool that allows you to substitute drivers on your local computer to the right one and reinstall them, and it helped me to fix some other computers there I have usually problems with driver installation. But once again, it's just in the case if you have a problem with drivers and if suddenly you cannot, computer cannot recognize your microcontroller in DFU mode. If you open STM32 Programmer and found that, okay, there is at least one USB connected to your computer and it was recognized, because if we disconnect this drone, it's going to be empty field here, we can potentially click connect button. And this tool will read everything what is on microcontroller. You can see that it just reads something, and it's like probably Betafly related thing. And we are going to open a file from our local disk, and it's something that we are planning to download into microcontroller. You can see there is a download button, and let's try to click download, and let's see what will happen. You can see that it started to erase the microcontroller, and after that it will try to place all this information into that. So download is in progress. Okay, file download complete. It takes just a few seconds, and let's see if it was updated. Yeah, so we can just try to read it once again, and we can compare device memory to that file that we just downloaded into the device. If we did everything correctly, now we can disconnect our flight controller from the computer, disconnect it from STM32 programmer, and launch Mission Planner tool. Let's do this. So I have Mission Planner. Mission Planner is the tool that will allow us to set up our Ardupilot flight controller. And you potentially can use other tools, for example, QGround Control, but I prefer to use Mission Planner. Prior to establish connectivity between Mission Planner and between our flight controller, let's look at Device Manager, and let's see if we have Ardupilot connected to USB device. Now you can see that we have a device, it's called Ardupilot, and looks like that at least it's recognized by Windows in my case. And my recommendation prior to establish connectivity, close STM32 programmer and probably disconnect your drone and connect it again to the computer. What we have to do, we have to pick after here in order to make sure that Ardupilot will automatically find our flight controller and connect it to the right port. So let's wait. Okay, looks like that it found something. And it started to read parameters. It's a good sign. It means that it has been recognized exactly as Ardupilot firmware. And for the first time, it takes some time to read everything. But once we start modifying parameters and from time to time connect and disconnect the drone, it's not going to take so much time anymore. Just a few seconds. And it looks like that it connected to COM 7 port. Let's see if it's still. Yeah, so it's COM 7 port. And map is not perfect here. But what we are going to do here, prior to start doing anything related to setup and configuration, we will need to look at several resources. First resource, it's a documentation related to MATEC itself. Because if flight controller supports Ardupilot, usually you can find some additional instructions. And if you visit MATEC website and flight controller for version 4, in our case, it's free, but it's the same. You can look at details, at least find mapping how some pins on the flight controller has been mapped to appropriate parameters, variables in the Ardupilot software. So for example, if you're talking, for example, about UART, you can see that we have Express LRS connected to TX6 RX6, and it's mapped to serial 7, not to serial 6. We have our companion computer connected to TX1 RX1, and it's mapped to serial 2. So it's very important to understand. And there are some additional instructions about how to enable, for example, camera switching, various instructions about what to do in order to enable TX-RX pins as a Express LRS related pins. So to make sure that we can take radio signals there, but it's not needed if you pick bidirectional D-short firmware because it's already enabled. So serial 7 enabled as UART, activated as UART there, so nothing should be done. And very similar page you can find in Ardupilot documentation. For example, this page related to all MATECs, and you can see almost the same instructions. You can see some important information that can be very useful probably for drone configuration. In our case, since we picked bidirectional D-short firmware, we can just note that in this case, serial protocol 7 is going to be initialized into 23, so it should be like converted into like general UART. It's something that we really need because we are using it as UART, so we are not going to set up it anymore. But anyway, once we read all these documents for your particular flight controller, you can go to Ardupilot documentation. Let me go back. And if you're talking about documentation, we obviously need to pick what kind of drone we are going to use. We are going to use copter. And my recommendation, read at least these two big, really big chunk of documentation about first time setup and first flight and tuning. If you look at first time setup, and if you look at Autopilot system assembly, for example, you can see like too many pages inside, but some of these pages are very important. One of the page that we are going to use right now, it's how to connect ESCs and motors. We have connected everything, but this page demonstrates different frames that are supported by Ardupilot, for example. In our case, we are using a frame from Betafly. Then we have motor numbers starting not like here, then we have motor number 1 here and 2 here, 2 here and 3 here. In Betafly, usually we have motor number 1 here, motor number 2 here, 3 here, and 4 here. And moreover, I set up my ESC in a way then motors are rotating to the center of the drone, to the side of the drone, rather than to the camera, because I don't want to put any kind of garbage into the camera. And if you look at all drone supported frames, you will be able to see that, oh, there is like Betafly reversed frame that is very similar to that one that we usually have in Betafly, with numeration like 1, 2, 3, 4, and with rotation to the side of the drone rather than to the camera. And obviously, it's important information because once we pick the right frame, and it's probably the first step that we are going to do, we are going to pick exactly this frame. So this documentation is very important. I will provide reference to some pages from here from time to time, but this is like first reference that I would like to provide. It's important for the first step. Let's go back to the mission planner and let's try to set up our drone. We are going to use two pages. First one setup, the second one config. Setup, it has in fact step-by-step tabs that we are going to click one by one in order to set up everything what we have there. And config allows us to get access to full parameter list. And it's a very important. It looks scary for the first time, but it's something that we are going to work with very often. So we will start with setup. And first step that we have here, frame type. Frame type, you can see that we are going to pick quadcopter from the list. And after that, we need to pick the right frame. And the problem that I just told that we need to pick Betafly reversed frame, but it's not available here. So what we have to do, it's the first time, then we need to go into config and go into parameter list. And you can see we have parameters split by categories. We have all parameters here, and we have some important buttons like write params, for example. Then we would like to modify something and write back to the flight controller, as well as search field. Let's try to use search field and let's try to type frame. And we have two parameters that started with frame keyword, frame class and frame type. Frame class in our case, quadrocopter, is something that we already picked from the list, but frame type is something that we still need to provide. And you can see there better naming here rather than just numbers, and we can see Betafly X reversed, frame type number 18. It's exactly what we need in order to satisfy our standard Betafly configuration. And we are going to write all these parameters back. So we just saved one parameter and we can click OK. but you can see reboot is required, and there is no button reboot here, but there is a trick. You can go into setup, you can pick compass and find reboot button here. So we are going to click it here, and drone is going to be rebooted and apply this important parameter. Alternatively, you can connect and disconnect drone again, but in this case, you need to connect button here. Click connect button here, since Ardupilot will not automatically connect your drone again if you disconnected your drone from USB. So we finalized frame type, and you can see that now it's picked like other. That is totally right. Next step, we are going to calibrate our compass accelerometer, sorry, and it's like a procedure that we will need to pass. Let me move my camera a little bit, and probably I will try to record the precision. So what I'm going to do here, I am going to click calibrate accelerometer button, and it tells, okay, place your drone in a level. So place it in horizontal position like this, and click done once it's ready. I can click done. Now it tells place it on the left side. Where's the left? It's here probably. So I am placing it on the left side of the drone and click done. It should not be very precise. It should be okay, even with no like perfect 90 degrees. Done. Now I can click done and place my drone to the right side of the drone. Click done once again. Now nose down like this, and click done. Click done. Nose up. It's much more complicated than you have antenna. And I always prefer to have antenna, since once you remove it, you will forget to attach it again once you provide power, and you will burn your VTX. Okay, place to the back, done, and calibration has been successfully completed. Now we even can calibrate level, so I will put my drone back and click calibrate level. Okay, completed as well. Next one is compass. Compass can be attached separately. My flight controller does not support compass. All compass can be used from GPS. My drone does not have GPS as well. There is a reason why I'm not attaching GPS, but it means that I don't have compass. So as for now, I'm going to turn all compasses off. And here we potentially click reboot to make sure that all parameters have been applied. And let's validate parameter list as well. So what I'm going to do, I can potentially type compass in search field, or I can potentially click compass as a category here. And you can see too many parameters, but one of the parameter is compass enable. We turned off all the compasses, but compass is still enabled by default. We need to disable it, because in this case, our Ardupilot will know that we don't have any compass. And we need to reboot once again. So go back to setup. And now we are on the right tab, rebooting our drone here. Next step, we need to calibrate radio, but it's not possible to do as for now, since we still don't know if radio is connected, at least radio module is connected to the right port and so on. So what we are going to do, we are going to go to serial ports tab to see what we have here. And my radio is connected to UART6, and we can see that here UART6 has been initialized into RSIN. It's exactly radio. So I'm not going to touch it at all, and I'm going to leave it as is. To UART4 on my Motec, I connected VTX, and I believe it's RC Trump protocol. So we will play with it probably next time, but as for now, I just would like to leave it as is. IRC Trump, and believe that it's going to work. It's not always true, but let's see. On UART 8, we have AC telemetry, but once again, probably we don't need to pick ESC telemetry, since we are going to use bidirectional D-short, at least we can just deal with it a little bit later. But if you are not using bidirectional D-short, ESC telemetry is your choice for UART 8, at least for MATEC. UART 3, we have nothing. We don't have GPS. UART 2, we have nothing. You can see that I told you that it's better to look at documentation to see mapping, but Ardupilot, if it's supported officially and if it's configured properly, Ardupilot already know which serial port mapped to which UART. So we don't need even to look at documentation at this point of time. And UART 1, I'm going to use Mavlink in order to communicate to the companion computer. So this setting is correct. Don't touch OTG2, probably because this stuff is used to communicate to your computer, and that's why I'm not touching any other Mov links, but at least UART1 is something that we need to have a Mov link to communicate with the companion computer. So done. I don't need to save anything here, so it had been applied once I change it. And now I can go to radio calibration. In order to do radio calibration, I need to turn on my radio, first of all, and I need to turn off my drone and turn on it once again to make sure that radio and my module can establish communication. And here I told that it's not going to be connected automatically, so I'm going to click connect button, and I hope it's not going to take much time. Okay, done. And my radio, I can see at least on my table that my radio has been completely connected. And now I can potentially move sticks. So I'm moving throttle, I'm moving yaw, let's see, pitch, roll, everything works as expected. But parameters of all these sticks should be initialized in a proper values. So that's why I'm going to click calibrate radio. It tells that I need to connect my transmitter to my module, and it's already done for me. And now I have to move all the sticks and click all the buttons to set up right parameters to them. Let's do this. I'm using sticks first, and let's do for all the sticks that I have. And now I can play with buttons. Free positional tumbler I have on channel 9. I'm going to remember this because I'm going to use this free positional tumbler to activate different flight modes. I have another tumbler that I'm going to use for arming on channel 5. Need to remember it as well. So looks like that this is not assigned. Another free positional tumbler to channel 6. We're not going to use it as for now. Let's click other buttons. What else I have? Okay, channel 7. And I have something interesting. Channel 8 and channel 7 for roller that I have here. Okay, so it just recognized all the values from my buttons and initialized minimum maximum values, and I can click done to finalize calibration. Let's see if I have one more button. Yeah, nothing else. So let's click done. And everything has been centered, and some changes had been recorded into the flight controller. Perfect. It's done, so potentially we calibrated everything. Now we would like to set up some buttons for arming and for mode selection, flight mode selection. I would start with flight mode selection. You can see that this tab tells us which modes are supported by Ardupilot, and by default we have stabilize everywhere. But what I'm going to do, I'm going to pick at least two modes. You can pick stabilize, for example, alt hold. That it's allows us to hold drone in a position with the same altitude. And acro, for example. Acro is not the real acro that we have in Betaflight. To have a real acro, what we are going to do, let's say, for example, this configuration, we are going to have into configuration, pick acro trainer parameter. It's in the top of the full list. And by default, you can see it has parameter that even in macro mode will use IMU sensor in order to try level your drone to make sure that it's not going to rotate and do anything strange. That usually it's a common situation in acro mode. So if you would like to have real acro mode, just disable acro trainer, and that's all. And second parameter that we are going to change, okay, we picked some flight modes, but we need to set up a channel. And I just thought that it will be worth to remember some channels, and I'm going to use channel 9 for flight mode changes because I have prepositional tumbler there. So what I'm going to do, I'm going to find parameter called FOT mode channel, this one. And you can see by default it's set into 5. For any kind of reason, I'm going to change it to 9. And it's the second parameter that I modified. And third parameter that I would like to see channel 5 receiver. So RC5 channel. And we can see that if we are talking about RC5, we have option here. Option allows us to assign a function that which channel is going to do. And in my case, it's going to do arm disarm for Ardupilot version 4.2 and higher. And it's number 153. And let's look at all modified parameters that I just completed, just modified, and we can see I modified acro trainer, I modified flight control, flight mode channel, I modified RC5 option parameter. And that's all what we need. We can write all these parameters, click yes. And let's go back to basic setup and let's start with what? Let's start with flight modes. Now I can click my free positional tumbler and can see that in the second position it's go to flight mode 4. It's because in second position it generate 1500 value for PWM, and that's why I have to move my alt hold into this position rather than into this. Now I can use my tumbler to switch between stabilize, alt hold, or acro. So everything works fine. If you have compass, obviously you can assign additional modes, and obviously for this you need to use different tumbler or different set of buttons. On my Radio Master, I have 6 buttons in a row that just treat it as a singular tumbler. And you can pick, for example, a mode that allows you to return to base, for example, RTL, or you can just pick a mode that just land your drone. Depends on your previous state. It can land into like a position directly under the drone or land anywhere where it's possible, or you can pick anything else. Yeah. So in my case, I don't have GPS, so I have limited abilities to pick the right mode, but at least I'm going to use stabilize, alt hold, and acro. And let's click save modes, and it has been done. So potentially, what I can do, potentially I can even try arm my drone. I hope it's not going to work, but at least it should show that it reacts to my button. Let's click arm, and let's go into messages. Yeah, so you can see something happening. It's trying to arm, but since I did not connect any batteries to my drone, it's not going to arm anything. Yeah, so that's why it tells disarm because I just don't have enough voltage. Great, at least we tested the button. We tested the button and go back to setup. What next? We finalized with serial ports. We need to work with server output a little bit, but first of all, we need to click AC calibration. AC calibration allows us to pick what kind of mode we are going to use in order to communicate to the motors. In our case, it's going to be G-Short 300. And you can set up some parameters there that tells how fast your motors are going to spin after, like, for example, arming, etc. And if you arm your drone and can see that your motors are not spinning, you can just increase this parameter. I'm not going to modify anything here, but I'm just pick G-Short here. And now we can go to server outputs. You can see that 4 at least outputs that are associated with my sticks had been assigned to different motors, motor 1, 2, 3, 4, and we don't have any clue about if it's the right direction, if motors are spinning in the right way, etc. So what we are going to do here, we are going to go into optional hardware, and we are going to go into motor test tab. So now it's time to connect our drone to the battery. Let's do this and see if we have motors rotating in the right position. If you can hear that your motors are beeping constantly and nothing works, probably just restart your drone, because AC calibration potentially should apply directional G-Short right away, but from time to time you need to restart it, even if it does not tell you to restart anything. So let's go to motor test again, and let's click test motor A to see if it's spinning at all. Okay, probably you don't see. Let's do motor C. You can see that it's spinning. Pay special attention that motor A is not motor 1. In our case, it's motor 2. So let's go back to our Betafly reverse configuration. You can see that A is 2, B is 1, C is 3, D is 4. And if we can see that motors are rotating exactly in the same direction, 1, 2, 3, 4, not in the same direction, but in the same order, yeah, we should be fine at least from motor sequence. Let's test this sequence. So motor 1 is going to be test motor B here. It's going to be bottom right motor. Yes, it's rotating. Motor C is going to be motor 3. It should be here. Okay, it's rotating. Motor D should be here. Rotating. Motor A is there. Rotating. Now, if suddenly you can see that direction is different, imagine you click motor A test, but this motor is rotating, you need to go to servo output and pick the right motor for A, B, C, D. In my case, for Betafly X reversed, motor 1, 2, 3, 4, it's the correct order here. Now I need to validate direction. I can test all the motors and see if they rotated into the right direction. In my case, it's going to be to the side of the drone. Okay, looks like that everything correct, but if suddenly something happening, you need to modify direction of the motor. It could be better to do it in advance, but even here, it's possible to do this. You just need to go into config and pick a parameter that has a name servo BLH auto. Let's type it. Servo BLH auto. By default, it's in 0. It means that it's not allow us to change motor settings using standard way that we are doing for BL Heli. Then we open a browser, open ESC configurator, for example, om32.k portal and set up motor direction using through beta 4i. But it's possible to enable this parameter and write params. Click OK, OK, and obviously reboot is required. But what we are going to do here, we are going to disconnect our drone. We are going to disconnect from USB, just in case we are going to disconnect it from the battery and connect it again to USB and to the battery. And I'm going to use Chrome. And let's pick IM32 from the list. IM32, and let's see if it's going to work. I need to pick port. If I remember correctly, it was COM7. Port selected, and let's click connect. Aha. Let's try 7 again. Oh, for the second time, it just treat everything. Yeah, so it requires some back and forth steps. Just try to connect, disconnect several times and totally turn off your drone. And once you can see that on your port you could read all the motors, you can click read information to see parameters of your motors. And here, obviously, you can modify position, how motor should be rotated, in which direction. You can set up some important parameters for M32, like number of kVs. In my case, I'm using 900 kVs motors. You can set up PWM type. I'm using fixed and using 24 kHz. And you can disable some probably not needed parameters, so enable them if you are not sure about your drone. For example, temperature limit can be very useful. So I'm not going to modify here anything since my motors are rotating into the right direction. I'm just going to disconnect. Disconnect, open mission pointer again, and let's click connect here. If it's going to be connected, if it's looks like okay, it's reading parameters. So we understood everything about motors, how to modify motors position or motors rotation direction. And we already modified flight mode. We aren't going to do anything with fail safe because we don't have GPS or anything like this. And it will just drop, yeah, probably, and that's all. But we would like to do initial tuning for our PID parameters. So what I'm going to do here, I'm going to pick my propeller size in inches, 10 inches. I'm going to pick parameters for my battery. I'm going to use LiPo battery. You can pick Leon if you use Leon battery. And I'm using 6 cells, and standard voltage, I believe it's about 4.2, and minimum voltage, let's do it 3.3. And we have to calculate initial parameters. So you can see that Ardupilot changed some parameters related to accelerometer, gyroscope, and we can write everything to ESC. After that, it returns one more message about that you have to modify something after the first flight. Why it's happening, what is it? Where is the first parameter that tells Ardupilot at least, which priority of your throttle stick against priority of the algorithm that is going to hold altitude. By default, it should be balanced 0.5, but as for now, for the first flight, it's set up into 0.1. So my recommendation, even if you're not going to learn anything during the first flight, you just set up this parameter in 0.5. And a couple more parameters, they help your drone be more stable than just hold altitude. It's related to motor thrust hardware than which thrust you can potentially use in order to start hovering. But once again, I'm not sure if it's something that can be learned very well. Yeah, so and you can potentially don't touch anything. After that, since we are going to go deeper and do tuning of PID of all parameters later using after tuning procedure, But at least this parameter you can set up into 0.5, or you can make experiment even with these parameters. What Ardupilot has been completed here? Ardupilot added one important parameter that called mod hover learn. Let's find this mod underscore hover learn. You can see it's like initialized into 2 after our procedure, and 2 means that it's going to learn and save exactly information about hover throttle. We can put it into 0, for example, and disable this learning opportunity since we're not going to probably use it. All opposite, we can put it into 2 anytime and try to start our drone, move it and hold it using like stable altitude for a few seconds to help our Ardupilot to learn this parameter. But once again, my recommendation, don't touch it at all and just set that parameter that we just discussed into 0.5. And later we'll initialize all other parameters. Since hovering, it's like a really tricky thing, especially if you are touching different payload to FPV. And in general, it's better to learn it with like that payload that you are planning to use. But if you don't know which one you're going to use, there is no sense probably to learn much. The same about PID, but our goal at least to set up PID in a way then we can demonstrate smooth flight using like any kind of general payload or expected payload for our drone. Okay, we can go back to setup. Looks like that we set up everything here. And one more thing that probably important is GPS. It's better to disable GPS for everything. Since we don't have GPS, let's type GPS parameter, and there should be GPS1, GPS1, and GPS2 at least. So GPS1 type is none, we don't have GPS. And GPS2, I believe, already into these values. Yeah, so it's already in 0. And we are going to write these parameters again. Okay. And let's do final reboot. Final reboot. Where is it? Compass. For any kind of reason, click reboot. Okay. And so it's done. It's done. And probably we can try even arm our drone. Let's see what will happen. I can potentially arm it from the flight controller. You can see where it's like not ready to arm. Let's see what kind of messages I have here, or what kind of pre-flight checks I have here. Oh, I have very low battery level here, and probably it's the reason why it's not ready to arm. I was using this battery for the whole day. Let me change it, and let me connect it once again. So I disconnect my battery, and I have another battery. Let's do it once again. Okay, now battery is fine. You can see all the checks that we are going to validate prior to flight. And let's arm again. And we can see another here related to logging failed, and we don't have logging at all. Yeah, so we can disable logging. Or alternatively, what we are going to do, we are going to go into config and look at arming parameters. And there is arming check. Arming check by default, it's all. And you can see there are many different parameters, including logging availability and including GPS. And in fact, we don't need logging, we don't need GPS. We can just have voltage that we probably would like to validate. We would like to validate channel availability, etc. But once again, depends on your mission and depends what you are going to do. You definitely, probably in some cases, would like to start your drone even with low battery voltage. So if you believe that everything is fine with your drone, just probably remove all these checks from here and close this window. or at least set checks that you really need. It's very important to write parameters. So let's do save everything, and we can go back to our data and try to arm again and see what kind of messages we have here and verify checks. Okay, finally, I have everything is in place. One more thing that probably worth to check if I have my camera. Let me just modify channel. My camera output, I have it here. It's coming from my companion computer, in fact, and you can see I have some the information. And probably next step will be about how to set up Mavlin connectivity between my companion computer and my flight controller, how to set up VTX parameters, and if it's possible to do anything with VTX, because it's not always possible in Ardupilot, but at least you can find lots of VTX related parameters. In fact, as for now, just one, but if you enable VTX, you should be able to see more parameters. Let's write all of them into the memory, and you can see a message that number of parameters are going to be available. And now you can see more parameters related to VTX. Potentially you can manage your VTX here, and you can potentially assign a channel to switch power for your VTX as well. And as for now, we can potentially fly. We can fly, it's not going to be stable, probably. And we still need to tune PID a little bit, but for today, it's good enough. Thank you.